Okay, so like I said, calculus starts with limits, derivatives from first principles, then derivatives using the rule. Let's also not forget to, let's also not forget that derivatives is simply another way of working out the gradient. Okay, so let's just make a mental note of that. Derivatives is actually just finding the gradient. So I'm using this letter M here to represent gradient. Okay. Next. What's next on the list? I think now we get to the cubic function. Okay. So why is it that the cubic function is thrown in with calculus? Why don't they just chuck this with the rest of functions like parabola and hyperbola, exponential, all of that functions? The reason they throw this in with calculus is because we actually use a bit of calculus to find the turning points to this function and also to find the, we use a bit of calculus to find the turning points as well as the inflection point, or what's the other thing I'm trying to get at? Oh, tangents to the function. So an example will be, let's say I have a point over here and there's a tangent to this graph at that point. If I want to find that exact point, or at maybe the gradient at that point, I can work it out using a bit of calculus. Okay, specifically the derivatives, because from our previous conclusion, derivatives was about finding the gradient. Okay, next, I think next is optimization. I feel like I'm skipping something here, but okay. Next is optimization. And the reason optimization is thrown in there is because we try and work out maximum or minimum values, or maybe try and figure out a position, a maximum position or a minimum position for whatever function or I guess object you are looking at, whether it's finding the maximum area or volume or speed. They give you different scenarios here and you kind of just have to work through these examples. And because we're dealing with functions and polynomial type functions, these functions generally have turning points. Okay, and specifically the cubic function has two turning points. It has a maximum turning point and then also a minimum turning point. Another word for these turning points are also called stationary points. So you'll often hear that. They'll refer to it as a stationary point. Okay. Now, enough with the kind of revision. Let's jump to, I guess, an exercise. And then I'll ask you guys to help me along with it, if that's okay. Right. Now, I hope you don't have any trouble with finding derivatives from first principles, but I do want us to go through that very first question as well. So, Nikita, can I start off with you? Because you said you did, I guess, the beginning half at least of calculus. So, what is the formula to find the derivative of a function from first principles? There's a very specific formula that we use.
Isn't it limits and then h going towards 0? And yes, and then it's if on top it's f, and then x minus h plus h minus fx.
That's correct.
And then at the bottom it's h.
Cool. Okay, so minor discrepancy there. It's a plus inside the bracket here, fx plus h, and then minus fx. Cool. So it should look like you are working out a gradient. We look at this fx plus h as your y2. This fx is your y1 divided by x2 minus x1. So this h represents the x2, which is the x plus h, minus the x1, which is x. If you take x plus h and minus x, you are just left with the h there at the bottom. Okay, so it should look similar to gradient. That's why there's a minus in the middle on top. And like I explained now, the x2 and the x1, once you minus them, you're left with an h. Cool. Now let's use this formula. First of all, let's figure out what is fx plus h, and then we're just going to substitute into this formula. Okay, so the function was given to us on top. I just need to go back and check what it was. Okay, so here's it. F of x is equal to 3x squared minus 1. F of x is equal to 3x squared minus 1. So if we want to work out what is f of x plus h, oopsie, we can just substitute x with x plus h. Okay. And then you can multiply everything out. Actually, let's first do the brackets. So we have x squared plus 2xh plus h squared. The minus 1 still chilling outside. Then we multiply with the 3 inside the brackets. And the 1 should not be multiplied by 3 because it's outside the bracket. So again, we just have the minus 1 there. Now, there are no like terms here. So I'll just leave, yeah, I guess I'll just leave it like that. So now let's use our answers here and substitute it into the formula. Remember, this part must be substituted with the first section, the fx plus h, and then this is then just substituted with the fx. Okay, now in that formula, fx plus h minus fx, we are minusing these two functions. Okay, notice now while you are minusing those functions, the 3x squared cancels with this 3x squared, and the minus 1 will cancel out with that minus 1 because you're minusing them from each other. So you are basically only left with that middle section, which is 6xh plus 3h squared. So that's the only part I'm going to write on top. Okay. So substituting into the formula, that section there is the only thing I'll write on top. So f of x limits as h approach 0, 6xh plus 3h squared divided by h. Okay. Sipusetu, how do I proceed from here?
You take out a common factor of h at the top.
And then?
Cancels with the bottom h.
Yep. And then?
You left it, and then you apply the limit and you left it 6x.
Yes, correct. Because what we are observing is as h goes to 0. So if h tends towards 0, that 3 becomes smaller and smaller, and eventually the 3 also becomes 0. Okay, because 3 multiplied by 0 will just be 0. And so, like she said, you are left with 6x. Okay, awesome. Now, I have made videos, if you are curious, on how to find the derivative of these functions when they are written like this, 1 over x, that's like a hyperbola, or like this, the square root of x, like in third form. Okay, so if you want to know how to find the derivative for these type of functions, I'll just send you the link for the 2 videos that I made on this. Well, I think it's 1 video, but yeah, I'll send you the link for that. However, the polynomial is more commonly asked. So this function 3x squared minus 1, that is more commonly asked than the others. So yeah, if you know that, then I guess it's good enough. We are also going to work out the derivative to these. And this time we're going to use the rule. Okay, so let's keep in mind, the rule is if x is to the power of some exponent, that exponent comes to the front, and then we deduct the exponent by 1. Okay. So let's start out with this one. We have y is equal to bracket square root of x plus x, and that is all squared. Find the derivative of y. Okay. Now, I want to start out by multiplying those brackets out, okay? So I'm going to multiply actually, I'm going to use the shortcut method. So whenever you have brackets squared, it's important to remember that you square the first bracket, square the sorry, not the first bracket, but you square the first term. You also square the last term, but in the middle term will be the product. So A times B, and you double that. Okay, so in the middle, you have a 2AB. Okay, I'll be using this approach now when we multiply those brackets out. So we're first going to square the x squared. Or sorry, the square root x. So when you square root x, you just have x. And then I'm going to square the last term, the x, and that gives me x squared. Okay. Now, I need to multiply square root x with x and then double it. I need to find a product and then double that product. So I will have 2, because 2 stands for the doubling of the product. And so what is x times square root x? Okay, square root x can be written as x to the power of a half, and x could be written as x to the power of 1. If I multiply these 2 things, I then have to add the exponents, which is then 1.5. And I can also write 1.5 as 3 over 2. Okay, so if I add a half with 1, I get 3 over 2. So here I'm just going to have x to the power of 3 over 2. Okay, perfect. Now I can remove the brackets actually, because I've already multiplied everything out. Jenna, could you give me the answer to this, please? I now need to find the derivative for y. Ooh, Jenna, did you do calculus before?
Oh yeah, I have.
You have, okay, awesome.
That's right. The y one.
Hey?
Finding the derivative for y equals x plus 2x to 3 over 2.
That's correct, yes.
Okay, I'm sorry, I'm just working it out.
No problem. So I'll just repeat the concept. Yes, would you like to give me the answer?
I got x plus 3x to the half plus 2x.
X plus 3x to the power of a half, and then?
Plus 2x.
Plus 2x. Okay, I do agree with these two.
Yeah, I think I messed up the first one. That's why I was getting a bit confused.
But I have, yes, definitely a fault here. What should the correct answer be?
1 times x is x.
You multiplying,
yeah,
multiplying the one in front, so it stays x. But when
Mm.
you minus the exponent by 1, remember the exponent becomes 0. And what is x to the power of 0? In fact, what's anything to the power of 0?
0. Okay, I see. Yeah, I was getting a bit confused with that.
Okay, so anything to the power of 0 is 1. And that exponent here being 1, once you deduct 1 from it, it's 0. And anything to the power of 0 is 1. I normally say if there's a term that just has an x, like 7x or 3x or even pi x, just take the number that's in front of the x, and the x kind of just disappears. Okay. Yeah, so that's it for the first one. Let's move over to the second one. Okay. So what do we have here? It's a quotient. We have 5 minus x over x. Okay, quotient simply means division or a fraction, like a ratio type. Now we can break this up just to make it simple or more simpler for us. We can break it up and it will look like this: 5 over x minus x over x. So instead of having it grouped together over the same denominator, I'm splitting it up. Okay. And then I'm also going to prepare it by, I guess, writing 5 over x as 5 multiplied by x to the power of -1. Okay, so the x at the bottom can be written as x to the power of -1. Okay. And then minus x over x, which is just simplified to 1. Okay. Now, Nikita, would you like to give us again the answer to this, please? The derivative of y for this function. So continuing from this point onwards.
So it would be -5 x to the power of -2, and then the 1 like goes away.
Yeah, correct. The derivative of a constant is 0, so that's why it goes away. Now, I will say that sometimes they do ask us to write our exponents in its positive form. So then you will have to take the x to the bottom again. So the final answer for this, I guess, will be -5 over x squared. Like that. So the exponent 2 becomes positive when you take it back to the bottom. Okay. So kind of a similar thing that happened here. X to the power of 1 was positive at the bottom, but once you took that x to the top, it became negative, x to the power of -1. Okay. Now, they won't always ask you to write it in its positive exponent form, but I just thought I'd show you that here as well. Okay, let's move along. Right, now we get to the cubic function. So I actually want you guys to copy down the equation of this function. Then I want you to also copy down a picture of this in your book right now. So I'll give you like a couple of minutes, maybe like 2 minutes to do that. And then in fact, I'll give you another 5 or 7 minutes to answer the 2 questions here as well. Okay, and then after all the time has passed, we'll work through it together and I'll see if you got the correct answers for that. Okay, so go ahead, copy down the question and the picture as well. Start with the questions and yeah, we'll reconvene in the next 10 minutes or so. Okay, so I just want to add, I guess, another question, or I guess a question that comes before question 1. So this cubic function with the equation x cubed minus 5x squared minus 8x plus 12, if the question was for us to find the x-intercepts of this function, can I just find out how would you guys go about this? So Nikita, I'll start with you. You want to find the x-intercepts of this function. How would you work that out? Finding the x-intercepts of a function. Now, I would say, because it's just like any other function, you start off by making y equal to 0. And I guess the next logical step is to factorize. But how do you factorize this equation? Like if you have 0 equal to x cubed minus 5x squared minus 8x minus plus 12, how do we factorize this? Jenna, do you maybe have any ideas here?
Don't you first find like you first make x1 minus 1 or whatever, just find the first bracket, and
So
then
you'll first just try and error to get a factor.
yeah, and then
Okay,
you do
and
the
once
second bracket.
Okay.
Oh.
So okay, wait. Let's try and substitute 1 to see if we get a factor. So I'm going to substitute 1 here. That gives me 1 cubed, which is 1. And then I substitute 1 there, 1 squared times -5, which is -5. And then this is just 1 times -8, which is -8. And if we add 12, this actually gives us 0, which means that 1 is a factor. Okay. So I guess you'll start out writing the first bracket as x minus 1. Is that correct?
Yeah, that's what I was trying to say.
Okay. Then after we get that first bracket, how do you now work out the second bracket?
What's the name of that division thingy you use?
Oh, synthetic division.
Yes, that, yeah.
Yes.
What's that?
Is this how you do it?
Yes.
Okay. So synthetic division is a way of dividing with polynomials. Like this, we have a cubic function, which is a polynomial. So we can use this method of synthetic division to factorize this cubic function. But sorry, back to what you were saying. Is it Jenna?
Yeah.
Back to what you were saying.
Oh, then I don't actually know what you do. I just know it's like x squared, and then it's like I can't remember. I think 6. Is it 6 at the end plus 6?
Okay, so can I help you out with this method?
Yeah, I always forget how to do it, like all the time.
Okay, so the reason why we're choosing x squared is because you're trying to end up with this first term there. So the x times the x squared gives you an x cubed.
Yeah.
Okay, so that's why we're choosing x squared. Then how we choose this last term here is we also have to look at the last term, which in this case is 12. So Negative 1 times what will give us a positive 12? Negative 1 times what?
Negative 1 times negative 12.
Negative 12, that's correct. Okay. So negative 1 times negative 12 gives us a positive 12. So now we need to find a middle term. And you could use either of the middle terms. I'll just stick with the first one, negative 5x squared. Okay. So you're trying to get negative 5x squared. Negative 1 times x squared is negative 1x squared. And so if you want to get negative 5x squared, you still need to minus a 4x squared. Okay, which means that this term in the middle should be minus 4x. Okay, and that's how you find that trinomial there. So now that you have that trinomial, you can just factorize that trinomial as well. Okay, so can we do that? We can factorize that trinomial. The factors of 12 to give us 4. What are the factors of 12 to give us 4?
6 and 2.
Yes. So you have x minus 6 and x plus 2. And there you go. So now your x-intercepts is 1, or it's 6, or it's negative 2. Guys, is this the only way to factorize a cubic function? Like, were you only taught synthetic division and I guess this guess and check method?
I don't know what synthetic division is. But me and Sipo got the same school. Sipo, did you learn it in AP?
I learned synthetic division in AP, and I think it's better because you're not sort of guessing.
You're not guessing, yeah.
Yeah.
It's a bit more precise.
Quite hard.
Okay, before I show you how to do synthetic division, come I'll show you an even lazier way of doing this. So take out your calculators quickly. And then press mode. And then I want you to go to table. So I guess it's button number 3 to go to the table. Or if you have the more fancier calculators, it will be button number 7, I think. Okay, you should get an FX now. And in FX, just punch in this function. Okay, I hope you know how to find an X in your calculator. Do you all know how to find an X? I hope so. Okay, so you just press, I think it's alpha, close bracket maybe. Alpha close bracket, and that's how you find an X. Anyways, tell me when you're done punching in the function.
I'm done.
Yeah, almost done.
Okay, so just press equal to. If it offers you a gx function, just press equal to again. We're gonna skip that. Now I want you to start at -9. So you press -9 and equal to. And then end at 9 and make your step 1.
Why are we starting with -9?
Oh, it's just, I want to have a big range. So I don't know where my x-intercept is. So maybe this x-intercept can be -9. So I just want to make it as big as possible.
Okay.
It's probably not going to be -9, but I'm just making it as big as possible.
Okay.
Okay, then you end at 9, make your step 1. You should have a table now that gives you x and y values. Okay. Yeah. Now remember, an x-intercept is where y is 0. So you need to go look where y is 0. Now go down the table and check where y is 0. What are the values where y is 0?
6.
You got 6, okay. Is that all?
12.
Really? You got 12?
-2.
Oh, yes, sorry.
1 and negative 1 and minus 2, -2. I think 12 is the y-intercept.
I was just looking at the wrong number then.
Yes. If you're looking at the x column, no. If you're looking at the y column, I think y would be 12 where x is 0. Yeah, so that's the y-intercept. That's not an x-intercept. Okay, so you just need to look at where y is 0. That's your x-intercepts. Okay, this is a much easier way of factorizing cubic functions. Like, you get the answer instantly, and your calculator did all the work for you.
So is that just the answers?
Yeah.
Of the entire
Like
thing?
if they were looking for the x-intercepts, then you found it using a calculator.
Oh, that's crazy.
Yeah, I mustn't teach you guys to be lazy. Let me just show the synthetic division also. Okay, so maybe write the word as well, so you don't forget it. Okay, so the factor that we found was 1. Okay, that was the first one that we found. We substituted 1 into the equation, it gave us 0. So we established that 1 was our factor. Okay, now you need to write down the coefficients of the cubic function. So the coefficient of x cubed is 1. The coefficient of x squared is -5. The coefficient of x is 8. And the constant, basically the coefficient of x to the power of 0, that is 12. Okay. So we'll start off by just bringing this one down. Let's just bring that one down. And then what we're going to do is multiply this one with that one. Okay, so 1 times 1 is just 1. Okay, I put it there. And now I'm going to add the -5 to the 1. Okay, so -5 plus 1 is equal to -4. Okay, and again, we're going to multiply now. So I'm going to multiply this one by the -4. So 1 times -4 is again just -4. And again, we're going to add now. So -8 plus -4, that gives us -12. Again, we're going to multiply. So it's just a pattern of adding and multiplying the whole time. So we multiply, we get -12 again. And then we add 12 with -12, and that gives us 0. Okay. Now you should always end up with 0. The reason why we always end up with 0 is because we found out that this factor of 1, once it's substituted into the equation, it gives us an answer of 0, meaning there's no remainders, okay? So when we divide it with this cubic function, there shouldn't be any remainders. Okay, so now you can just add, or I guess now you have the what do you call this? The coefficients for your trinomial. This is x squared, this is x, and then this is the constant that doesn't have the x. So that's a trinomial that we factorized the last time. And then we ended up with -6 and +2. Okay, so there you go. That's how you do synthetic division. I did, however, make a more elaborate video explaining all of this and doing multiple examples. I also show in that video how to factorize these cubic functions using like completely different methods as well. Not just the calculator method, but also a grouping method, and there's probably something else also. I don't know. I showed like 4 different methods in that video. So I'll definitely send the link in the group and you guys can go check it out. Let me just check what's the time now. I don't want us to go overboard. So, okay, coming back to question 3.1 and 3.2. Calculate the coordinates of the turning point of f. Okay, so to find the turning point to this function, you need to first take the derivative and make it equal to 0. Okay, so the derivative of that function was 3x squared minus 10x minus 8. Okay, and so we factorize this. It's 3x and x. And then the factors of 8 will be 4 and 2. The 4 should get a negative and the 2 should get a positive. So I guess the possible x values is -2/3 or 4. Okay. The reason we're choosing 4 as our answer is because it's on the positive side of the graph. Okay, so B's coordinate has to be 4. And then to work out the y coordinate, which we said was -36, to work out that coordinate, you actually need to substitute this 4 into the original equation. So you substitute 4 into this equation, x cubed minus 5x squared minus 8x plus 12. And that should hopefully give us this -36. Okay. Okay, so we'll just zoom out to find the next question. Oh, the values of x for which the graph is concave up. Okay, whenever they talk about this concavity, or when the graph changes concavity, concave down would be where it's less than 0. Concave up is where the second derivative is greater than 0. Okay, so greater than 0, let's first write down the second derivative. This is simply the derivative of the derivative. And so you can just take the 10 across and then divide by 6, which we calculated as 5/3. Cool. You're just simplifying the 10/6. So that's how you get the 5/3. Right. I do have a last question here, but I don't think we're going to have time to actually get to it. So I'd like to give you guys this question as homework. Have a look at it. The sketch is not drawn to scale. But yeah, take a picture of it, or I guess copy it down. I did send it in the WhatsApp group as well. Work out the values for A, B, C, and D for this function. Okay. If you struggle with it, let me know, and then I'll assist you guys that way. Anyways, we'll end our lesson here.